Hello class. Today we're going to be going over section 2.3, properties of trigonometric functions. This first chart that I'm providing for you is indicating the domain and range for each of the trig functions, for sine, cosine, tangent, cosecant, secant, and cotangent. We'll go into greater detail into these four when we graph, so you guys can see there's vertical asymptotes, and so there's points of discontinuity in the domains, and then the ranges, again, I'll talk about when we get into really graphing, but this is a chart so that you guys can peruse and see if you understand it. Okay, when we're talking about the period, this is an excellent chart. What this chart demonstrates is it shows the periods for each of the functions. So we can see, like for sine, which is this first one, the period is 2 pi. For cosine, it's 2 pi. For cosecant, it's 2 pi. And secant, it's 2 pi. And then for tangent and cotangent, their period is pi. Now, what a period means is it's a repetition. So basically, if I were to go and graph sine for you, don't worry if you don't totally understand. It's okay. It's going to look something like this. So and you can see that at every 2 pi marker, you're in the same position. So all it's saying is it's going to repeat and be at the exact same spot it's going to have the same y value at every period of 2 pi. So if I chose any point, so if I chose this point here, which is pi over 2, 2 pi away, so from here to here is 2 pi away, I'm in the same position. That's basically what it's saying. So let's do some examples algebraically, and then from there we'll move forward. So with sine of 17 pi over 4, what we want to do is we want to try to break this down into sines of period. So we know that the period for sine is 2 pi, so we want something that's going to be a multiple of 2 pi in this sine conversation that we're having. So I'm going to go sine of pi over 4 plus 16 pi over 4. And we can see from here that we have sine of pi over 4 plus 8 pi. Oh, terrible. 4 pi. And 4 pi is a multiple of 2 pi. So with that, we know that sine of 4 pi is going to always fall in the same position. So if we look at it, because I just want to give it to you, this right here is 0. After one rotation, I'll have done 2 pi. If I do it again, that'd be 4 pi. Doing it again, 6 pi. And then again, I'm at 8 pi. Now, if we remember, this point here is 1, 0, and sine is the y coordinate, right? Y over the radius, so 0 over 1. So we know that this is simply going to be a value of 0. So that's equal to sine of pi over 4. And sine of pi over 4, if you pull out your unit circle table, it should be radical 2 over 2. Because what we end up having is a 45-degree angle, or a pi over 4 angle, and this point over here is at radical 2 over 2, radical 2 over 2 on the unit circle. So it'd be somewhere over here. Okay, now let's look at cosine of 5 pi. So again, we know that the period for 5 pi, or the period for cosine is 2 pi. So then cosine of pi plus 4 pi is equal to cosine of pi. It's in the same position. So again, it's the rotations, right? So if I look at the unit circle and I go to here, that's pi. Once I come fully around, that's 2 pi. If I come back around again, this would be 3 pi. Coming over here would be 4 pi, because half of a circle is pi distance. The full circle is 2 pi. So then 5 pi would be this position, and that point, if we remember, is negative 1, 0. And so cosine of pi should be a negative 1. All right, let's try it for a different period. So tangent, we know that tangent has a period of pi. So the period for tangent is pi. So now when we look at this, we want to break this down in terms of a pi distance. So we're going to go pi over 4 plus 4 pi over 4. And we can see that this is pi over 4 plus pi. And again, what we're doing here is we know that tan of pi is going to be 0. So we end up with tangent of pi over 4. And I can just show you real quick. This is where pi is, right? And so the point there is negative 1, 0. And remember, tangent of the angle is equal to y over x. So in this case, we'd get 0 over negative 1. So tangent of pi, I can even just put pi over here. Tangent of theta up there. This one's going to be tangent of pi. We can see the tangent of pi is 0. And so when we get to the pi over 4 piece, it's important that we understand if that's pi over 4, adding pi to that would put us over here. This is where 5 pi over 4 is, right? So you're going to use that starting position and then rotate, adding a full pi or half circle to it to get to the 5 pi over 4. Well, the value here is negative radical 2 over 2, comma negative radical 2 over 2. And tangent is dividing those. They're the same, and so we get the value of 1, right? Because it'd be radical 2 over 2 divided by radical 2 over 2 negative. That equals the 1. Okay. Now to determine the signs of these trigonometric functions, something one of my teachers told me years ago, in quadrant 1, so again, let's just label these real quick: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. My teacher told me all students take calculus. And at the time, I thought there was no way that I'd ever be doing that, but I guess she turned out to be right about that. So in quadrant 1, all trigonometric functions are positive. So in quadrant 1, all are positive. In quadrant 2, students, it's going to be sine that's positive. Sine that's positive, and so sine's reciprocal is also going to be positive. So then that means that cosecant is positive. In quadrant 3, the take, see that all of them, the student's S is sine. The take T is for tangent. And so its reciprocal is also going to be there. So the way I always remember it is with all, sine, tangent, and then calculus will be cosine, and secant, because secant is reciprocal. So that's how I know which trigonometric functions, positive in whichever quadrant. Okay, some identities. These are important, big. In fact, I would say you should memorize all of these. The ratios for tangent, cosecant, secant, and cotangent, those are important. And then these three down below are identities that are very, very important. We're going to do a lot with these, so I would work on memorizing them. I'll show you a trick next time. If you know this one, we can get all of the others. So knowing that one should suffice to get the other two. But the ones above, those ratios, you need to know. Like, so you should memorize this, 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 this. And then if you remember that cotangent is just the reciprocal, that fifth one isn't that big a deal, but the other four you definitely need to know. So let's do an example using those to see if we can solve these problems. So tangent of 20 degrees, unless we used a calculator, we couldn't really figure this out. But right now what we're trying to do is do it algebraically, and so what I'm going to do is I see that sine over cosine is this tangent one, so I'm going to do that. So I'm going to say, all right, tangent of 20 degrees minus this ratio is tangent. So what's the degree? 20 degrees. So what's tangent of 20 degrees minus tangent of 20 degrees? You guessed it, it's 0. Okay. Now, secant is really, secant theta we know is going to be 1 over cosine, right? 1 over cosine, we can see that from up here. Secant's right there, and we can see that secant is that 1 over cosine, and so I'm going to go sine squared of pi over 12 plus 1 over 1 over cosine squared of pi over 12. And so when we divide by a fraction, we need to multiply by the reciprocal, right? So I'm going to go sine squared of pi over 12 plus 1 times cosine of pi over 12 divided by 1, which is the same as sine squared of pi over 12 plus cosine squared of pi over 12. And notice something kind of important. Sine squared of whatever angle plus cosine squared of whatever angle is equal to 1. That's why these identities are so important, because if you can see a pattern, it's giving you values and answers. So that's something that should be useful. Let's move forward. All right. So in this problem here, we're given the information, two things. We're given that sine is 1/3, so sine's positive, and cosine's negative. So remember, it was all sines, right? Sine, cosine, and its reciprocal. Oh, I did it wrong. Tangent and its reciprocal, and then cosine and its reciprocal. So that's where they're positive. So we can see that sine is positive in the first and third quadrant, but cosine's negative. So since cosine's negative, that tells us that we have to be in the second quadrant. Okay? Now something important, again, to remember is that sine of the angle, theta, is equal to our y coordinate over the radius. So what we know is that sine is going to be at 1 and the radius is 3. So if the radius is 3, let's just see if we can do this circle, right? So graphing this circle, it's going to look something like this, right? It's not a very good circle. But you can see that the point that I'm looking at, the sine value is 1, and the radius from here to here is 3. So now we know that the point, this point right here, really is, I don't know the x-coordinate, but I know that y is 1. Now that we have that, let's do some simple stuff for this problem, see if we can figure it out. So I know that sine is 1/3. So remember, its reciprocal is cosecant. So the reciprocal simply is 3/1 or just 3. Cool. Before we did any math, we should get the two easiest ones out of the way. Now, if we remember what a circle is x squared plus y squared is equal to r squared. Well, we know a lot of information here. I don't know the x squared, but I do know that y is 1, so that's squared, and we know the radius is 3, so that's squared. That's going to give us x squared plus 1 is equal to 9, so x squared is equal to 8, and x is equal to plus or minus the square root of 8, which is x is equal to plus or minus 2 radical 2. Now the important thing to remember is, what quadrant are we in? We're in the second quadrant, so it's the negative. So then x really is negative 2 radical 2. Now that we have that information, we got to remember that, that's important. We're going to be able to get the others. So cosine theta, remember, is x over y. So x over y would be a negative 2 square root of 2 over the radius is 3, right? So we know y was 1. X now we know is negative 2 radical 2, and r is 3. So we have cosine. The reciprocal of cosine is secant, and secant theta then would be simply be 3 over a negative 2 radical 2, but we always want to clean that up, and so we'd multiply by radical 2 top and bottom. So we get 3 radical 2 negative over 4. I'll put the answers and highlight them so you guys have them. Now we have that. Let's go after tangent. And tangent theta is equal to y over r and y over x. So y over x is y is 1, and x is a negative 2 radical 2. So again, we simplify by multiplying top and bottom by radical 2. So I'm going to get radical 2 over 4. And then we have to have our negative sign. Now, cotangent, I'll put it right here, cotangent theta is going to be x over y. So it's a negative 2 radical 2 over y, which is 1. And that cleans up to be a negative 2 radical 2. And I don't need the fraction because we have it. And there's the answer for cotangent. So that's one way to do it. Another way to do it would be to use the identities that I just gave you. So let's try and attack it that way. So again, remember, we have sine theta was equal to 1/3. And then we're going to use the identity to solve it. So I'm going to use sine squared theta plus cosine squared theta is equal to 1. So this is just another way to do it. Okay. Now, from here, if I substitute, I'm going to get 1/3 squared plus cosine squared theta is equal to 1. That's going to give me 1/9 plus cosine squared theta is equal to 1. Subtracting the 1 from both sides, I'm going to get 1 minus 1 over 9 or cosine squared theta is equal to 8 over 9. And then when I take the square root of that, I'm going to get cosine theta is equal to 3, and the top is going to clean up to be 2 radical 2, and it's plus or minus. But again, here we need to remember we are in quadrant 2, so it has to be the negative case, so cosine theta is negative 2 radical 2 over 3. Now let's see if that matches. See if I did this math right. So I have negative 2 radical 2 over 3, and I have negative 2 radical 2 over 3. So they are, in fact, the same. Good. So now that I have that, I can find all the others by using the ratios that we had just seen. So remember, tangent, it really is sine over cosine. So since it's sine over cosine, I'm going to go 1/3 over a negative 2 radical 2 over 3, which will clean up to be a negative radical 2 over 4. So a negative 2 radical 2 over 4 for tangent. Oh, I didn't highlight it. Yep, same answer. Good. Now to get cotangent, because cotangent's the reciprocal, right? It's cosine over sine. So I'm going to get a negative 2 radical 2 over 3 over 1/3. And that's going to clean up to get to be a negative 2 radical 2. And we see that's the same. So yep, that's good. That's good. This one's good. We got that one. Oh, I forgot to do the easiest one. The easiest one is cosecant theta, which is simply 1 over sine theta. So that's the same as 1 over 1/3. We multiply by the reciprocal and we get 3. And indeed we get 3. Cosine, we did cosine, I'm sorry. Secant is the one we didn't do, secant theta. So it's the reciprocal of cosine. So it's 1 over cosine theta, which would be 1 over negative 2 radical 2 over 3. When we flip that, we're going to get 3 over a negative 2 radical 2. But multiplying top and bottom by that radical 2, we're going to get 3 radical 2 negative over 4. And let's see, does that count as the same? It looks like secant is correct. So I have all of them. So there's 2 ways to do it. One using the identity and the other using the formula for a circle. So this is the formula for a circle. X squared plus y squared is equal to r squared. And then here what I used is the identity to be able to solve it. Okay, let's talk about odd and even functions for trigonometric functions. So if we remember our odd and evens, f of negative x is equal to x is an even function, and f of negative x is equal to a negative x is an odd function. So we can quickly see which ones are odd. Sine is odd, cosecant is odd, and tangent is odd because you end up with the negative x. Cosine, secant, and negative, and cosine and secant are also even. So let's look at this. So we know that sine then is going to be odd. So we're going to get negative sine of 45 degrees. And that's going to be negative. And 45 degrees we know from the unit circle is a negative radical 2 over 2. And sine is positive radical 2 over 2. But because we have the negative in front, we end up with a negative radical 2 over 2. Now, let me do one last example, and then we'll call it a day. Tangent of pi over 4 plus 36 pi over 4. That's going to become, and I need the negative, I put the negative out front. Negative tangent of pi over 4 plus 9 pi. And by remembering the period, we know that this is equivalent to negative tangent pi over 4. And that's going to be a negative pi over 4 for tangent is 1. And so our answer ends up being negative 1. I hope this has been helpful. Again, if you have any questions or anything, please feel free to leave me a message either on here or in our shell for the class. Have a great day. All the best.